Imagine a planet orbiting a star, not too different from our own sun, a place where oceans could shimmer under alien skies, where winds sweep across landscapes still untouched by human eyes. Now imagine this world isn't buried deep in some unreachable corner of the galaxy, but right in our own cosmic neighborhood. Meet Proxima Centauri b, a planet orbiting the nearest star to our solar system, just 4.2 light-years away. It's a world that has intrigued astronomers ever since its discovery in 2016. Why? Because this small, rocky planet might just lie within the habitable zone, the delicate range of distances where liquid water could exist on a planet's surface. Today, we're diving deep into the mysteries of this extraordinary exoplanet, its environment, its challenges, and whether it could, just maybe, harbor life. Proxima Centauri is part of the Alpha Centauri star system, the closest stellar system to Earth. Orbiting this faint red dwarf is Proxima Centauri b, a planet that instantly captured the imagination of scientists and dreamers alike. Its proximity makes it unique. For light years may sound far, but in cosmic terms, it's right next door. At that distance, signals from Earth would take only a little over 4 years to reach it. Early observations suggested something remarkable, a planet roughly the size of Earth, orbiting within its star's potential habitable zone. That combination, Earth-sized, nearby, and possibly temperate, makes it our most accessible interstellar target for future exploration. For the first time, humanity found a potentially Earth-like world within our technological reach. But before we get carried away, we need to ask a tough question. What does habitable really mean? Around a red dwarf like Proxima Centauri, the habitable zone sits much closer to the star, so close that the planet may be tidally locked. That means one side of the planet always faces the star in eternal daylight, while the other side is locked in endless night. On the day side, temperatures could soar high enough to vaporize surface water. On the night side, the cold could freeze the atmosphere solid. Yet, nature loves balance. Scientists propose that if Proxima b has a dense atmosphere, it could redistribute heat between hemispheres, creating a terminator zone, a narrow twilight band between day and night where temperatures might just allow liquid water to exist. Picture a dim, permanent sunset across an alien horizon, half the world bathed in light, half in darkness, and life possibly clinging to the edge in between. For any planet to be truly habitable, it needs 3 key ingredients: a stable atmosphere, the presence of liquid water, and a protective magnetic field. A thick atmosphere helps trap heat, keeping surface temperatures stable. It also acts as a shield against radiation, a serious concern near an active red dwarf. Liquid water is, of course, the holy grail. It's the universal solvent for biological chemistry. Wherever we've found water on Earth, we've found life, from boiling vents on the ocean floor to the icy deserts of Antarctica. And then there's the magnetic field, an invisible guardian generated by the movement of molten iron within a planet's core. Without it, solar winds and radiation can strip away the atmosphere, as happened to Mars. If Proxima b possesses a strong magnetic field, it could preserve its air and protect its potential oceans, giving it a fighting chance to remain habitable in the harsh light of a red dwarf. Proxima Centauri b holds a unique position in our search for extraterrestrial life. This terrestrial planet completes an orbit in just 11.2 Earth days. With a minimum mass of about 1.3 times that of Earth, it's believed to be a rocky world. Despite these conditions, Proxima Centauri b resides within its star's habitable zone, where temperatures could theoretically allow for liquid water. It receives about 70% of the infrared energy Earth gets from our Sun, a significant amount for a star emitting only 0.17% of the Sun's total energy. But it's not all good news. Red dwarfs, while small and cool, are notoriously volatile. Proxima Centauri frequently unleashes powerful stellar flares, blasts of radiation thousands of times stronger than those from our Sun. These flares can bombard Proxima b with high-energy particles, potentially eroding its atmosphere over time. In 2017, One of the largest flares recorded was 1,000 times brighter than the star normally is, and 10 times brighter than the largest flares our sun is capable of. The planet's close orbit also exposes it to intense X-ray and ultraviolet radiation, making surface conditions challenging for any form of life. Proxima Centauri b receives about 10 to 60 times as much of this radiation, especially X-rays, as Earth. If tidally locked, extreme temperature differences between the day and night sides could make life difficult, with one side scorching and the other freezing. And while we can estimate its mass and orbital distance, we still don't know what its atmosphere is made of, or even if it has one. That's the missing piece in this cosmic puzzle. Without a protective atmosphere, the planet would be more vulnerable to radiation and temperature extremes. Its atmosphere, if present, might consist mainly of hydrogen and helium, unlike Earth's oxygen and nitrogen-rich air. Until we know what surrounds Proxima b, we can only speculate whether it's a barren rock or a living world hidden behind layers of protective air. The good news? We're entering a golden age of exoplanet science. New telescopes, like the James Webb Space Telescope, and future missions such as LUVOIR and HABEX, are designed to peer into the atmospheres of distant worlds. By analyzing how starlight filters through a planet's air, scientists can detect gases like oxygen, methane, or water vapor. These are chemical fingerprints that hint at biological activity, offering clues to potential life beyond Earth. Proxima Centauri b is at the top of that target list, a prime candidate for atmospheric study. Beyond telescopes, engineers are even designing interstellar probes that could one day reach the Alpha Centauri system within a human lifetime. These tiny spacecraft, propelled by laser sails, would travel at a fraction of the speed of light, making the journey feasible. Studying Proxima b isn't just about curiosity. It's about answering one of humanity's oldest questions. Are we alone? Proxima Centauri b reminds us that the universe is not empty. It's full of possibilities waiting to be explored. Every new discovery, every telescope image, and every spectroscopic hint brings us a step closer to understanding our place in the cosmos. Perhaps orbiting that faint red star just 4 light years away, there lies a world where alien clouds drift over alien seas. And life, in some form, is already looking back at us. Until we know for sure, we'll keep searching. Because the quest to find another Earth is ultimately the quest to understand ourselves. Please subscribe to Scientific Valley for more interesting videos.